What I want you to do is one of the partners is going to do a factor tree for 8 and then hold it up when you're done. Doesn't matter whether you do left or right side. Do it on the left. Okay, everything looks good. You've circled your prime factors. Pate, you got to circle your prime factors. And you wind up with 2, 2, 2, right? Okay, hand it over to your partner. Your partner's going to do a factor. Don't erase anything, by the way. Your partner's going to do a factor tree for 12. Looks good. You got your prime factors being 2, 2, 3, right? Okay, now discuss with your partner and get the GCF of both numbers. GCF. After finding your GCF of 4, and 4 being the greatest number that can go into 8 and 12, I want you to find a number that both 8 and 12 can go into. You're writing down 2. 8 can't go into 2, and 12 can't go into 2. You have 2. 8 can't go into 2. 12 can't go into 2. So it's now that you're holding it up, I think you're realizing that the number is going to be significantly higher, right? What do you got? Most of you got it as 24, right? Okay, my next question. When you found 24, what is 24, or what is this called? Raise your hand, please. Juliana. That is called your least or your lowest common multiple. Okay? So now I want you to think for a minute. When I ask you to find the LCM, it has to be a number that's equal to or greater than the higher of the two numbers, 8 and 12. See, when I ask you to find GCF, GCF has to be a number that's lower or equal to 8. However, LCM has to be a number that's equal to or greater than 12. Is it starting to kind of make sense? Mm-hmm. How did you come up with 24? How did you do it? Barge.
Well, I saw it says 12 times 2 is 24, and then 8 times 3 is 24.
So you kind of started to count up by 12 and count up and realize, okay, it's got to be a number that's higher than 12. And then you were able to figure out, once you hit 24, you're like, can 8 go into it? It can, so it's got to be 24. By the way, 48. Will 8 go into 48? Will 12 go into 48? However, it's not the lowest common multiple. When we do LCM, we always want to know what the lowest number is that 8 and 12 will go into. Okay, erase everything, return your boards, and return your markers. We've already done this on the marker boards, okay? When we did 8 and 12, we found the GCF being 4. That 4 means that 4 is what? Who can summarize what we just talked about? 4 is what? Brandon. All right, put it into words though, bud. It is the GCF, but put it into words. What is it that you're finding? See, that's what I'm saying. We throw around GCF and greatest common factor. Put it into words. What is that number 4 represent? Sills. Right, it's the greatest number that can go into 8 and 12 equally. And when we say evenly, it means there's no remainder. And we already tested. We said, well, 5 won't work, 6 won't work, 7 doesn't work. 8 will go into 8, but it doesn't go into 12. And then 9, 10, and 11 will not work. So 4 is the greatest. Now, 2 will work for both, but it's not the greatest. Then I asked you, okay, what's the smallest number that 8 and 12 can go into? And we came up with 24. That's our LCM. That's the lowest number that both 8 and 12 can go into. I'm going to show you 3 different ways to find LCM, and we'll practice it today and tomorrow. And then in the end, you pick what works best for you. And I'll give you the advantages and disadvantages of each. Method 1 we call skip count. So let's say I want to find the LCM of 6 and 9. You can count by 6s, count by 9s, and the first number that you come to, the lowest number that you come to in common, in this case 18, that's your LCM. And it works fine. My advice to you is, if you're not great with times tables, like you have to know your 6 times tables and you got to know your 9 times tables. You got to be able to rattle it off quickly, 6, 12, 18, 24. You got to be able to do that pretty quickly. Because if you miscount, and the number that you miscount, let's say you do 6, 12, 15, 21, and you skip that 18, and you need that 18, you're not going to get the LCM right. So if you're good with times tables and the numbers are small, go for it. And that's my second advice or word of warning to you, is if you know your times tables and the numbers are small, less than 12, then method 1 is fine. But when you start getting like numbers like counting by 13s and 14s, it's a little bit more tricky. 13, 26, 39, and you got to start thinking. 52. So that's why I want to expose you to methods 2 and 3. Okay, here's method 2. Same numbers, 6 and 9. What was our LCM again? Because we don't want to forget it. What was it? It was 18, right? Put it up in the upper right-hand corner, because no matter what method we use, we need to come up with 18 as our LCM. Okay, here's how it starts. Do a factor tree for 6 and 9, and stop there when you're done. Laney, what do you got for 6? Both primes, circle it. And Karen, what about 9?
3.
Great. All right, next step, find the GCF. Dan?
3.
It is 3. Ready? Ready? Here it comes. You ready? What were the 2 original numbers? 6 and 9, right? Multiply it. What's 6 times 9? 54. Ready? 54 divided by the GCF of 3. What do you get? Can't do it in your head? Do it long division. 54 divided by 3. What do you get? Pay.
18.
Look at that. That's our LCM, 18. Okay, so method 2 is it's the original numbers multiplied together divided by the GCF. Okay, let's practice it real quick. There's still some space somewhere. Let's do 4 and 6. Factor tree for 4, factor tree for 6. Go for it. Yeah, Jay.
It says that these percentages, why won't this method work with numbers?
It does not work for 3 numbers. We have to use methods 1 and 3. It just doesn't. 2 for 4, Jay. 2 for 4. Nick, 2 for 6. 3 and what? What's our GCF, Matt?
It is 2.
It's 2. Ready? 4 times 6, everybody.
24.
24 divided by 2, everybody.
12.
The LCM is 12.
12. 12. 12. 12.
It's the original numbers multiplied together divided by the GCF. That's method 2. Watch this. Make it even easier. Ready? 4 and 5. What's the GCF of 4 and 5? What's the GCF of 4 and 5?
Nothing.
1 or nothing, right? 5 is prime and 4 is 2 and 2, but neither one are common. Ready? What's 4 times 5? The LCM is 20. If the numbers do not have a GCF, or the numbers are prime, then you get LCM by just multiplying those two numbers together and you're done. Okay? Sometimes that could be easier. 19 and 2. 19's prime, 2 is prime. Multiply it together, what do you get?
38.
38, you can do it in your head, right? Now, you tell me, what's easier? Counting by 19s or counting by 2s?
19.
I'm sorry, counting by 9s and 2s or just multiplying the two numbers together? That's method 2. So sometimes skip count works better, sometimes method 2 works better. Disadvantage, Jay already brought it up. Besides watching out for careless math errors, because I've seen it, 9 times 6 and people will write down 45 or whatever it might be, it does not work when we need to do 3 numbers. When we have to do LCM of 3 numbers, you have to do either skip count, method 1, or I'm now going to show you method 3. Right off the bat, you're probably not going to like 3, but after kids practice 3, they kind of like it the best. It's just something that you need to practice it a little bit, and then kids wind up liking it the best. And what's great about it is it does work great for 3 numbers as well. It starts off the same way. Find your factor trees, your prime factorization for 6 and 9. If you want to just copy it from the last page, you can, because it's nothing different. Okay, ready? Follow the steps, because if you do this, if you do method 3, you've got to do it exactly the way I show you. It's all about order and organization and doing things very, very methodologically. Methodically is the word I'm looking for. Mythological is some kind of creature from the mythology unit. Getting confused with math. Okay. A prime factor you see in both. Kira, ready? Cross out in both trees, list it. List it only once. Okay, next, do you see anything else that's common in both trees? Okay, there is not, right? Anything that's circled that is not crossed out is what we call the leftover numbers. And the LCM is the common factor times the leftover numbers, which is 2 and 3. Now multiply it all together, and what do you wind up getting? 18.
Oh, wow.
Okay? It's the common numbers times the leftover numbers. Watch, let's practice it. Let's find the LCM of 12 and 60. Break down 12, break down 60 into its prime factors like we've been doing. 60, 60. All right, Matthew, 2 for 12. 2 for 6. Connor, 2 for 60. Kevin, 2 for 30. Lily, 2 for 15. It's okay if you did it a different way. We're going to still wind up with the same prime factors at the end. You could start this out 10 and 6. You could start this out 12 and 5. You'll see we'll still have the same prime factors at the end. Okay, ready? Here it goes. Give me a number you see in both trees. Emily. Here's a 3. Here's a 3. We only list it once. going to do it in a different color. Okay. What else do you see common in both trees? Is cross them both out, but only list it once. What else? Anna. Yup, there's another 2 here. Cross them both out, but only list it once. Anything else? Leah, anything else? Okay, you go with your question. Yes. And you'll see that's the direction it's going. So we don't have any more common factors, right? Whatever's not crossed out, in this case, it's a 5. There's only one number that's left over. We have to add it to the multiplication string. Whatever number you see, you add it. Now it's 3 times 2 times 2 times 5. You have to multiply correctly, and if you want, you can chunk it. You can do 3 times 2 is 6, and you can do 2 times 5 is 10, and then multiply those two numbers together. What do you got? 60 is our LCM. 60 is our LCM. Because remember, our LCM can be equal to the higher number. It just can't be less than the higher number. Okay? All right, one last thing before we close today. We talked about this. If the two numbers don't have a GCF, or both numbers are prime, you can find the LCM by doing what? Once again, if our two numbers do not have a GCF, or the numbers are prime, we can find LCM by doing what? Dan? Multiplying the two numbers together. So if you have 11, which is prime, and 5 is prime, the LCM is 55. Tomorrow we're going to do the LCM of 3 numbers using methods 1 and 3, because 2 will not work. Okay? Pack up. Make sure that you have lesson booklet 18 tonight, because your homework is really in 18. Nothing is in 19.